and welcome to the show. It is great to have you with us. The number of women entering science, tech, engineering, and math careers are growing, but just at a snail's pace. A new report by TD Economics highlights this issue, but also says that it could be a major factor in the gender gap as a whole. Beata Caranci is the chief economist at TD. She joined me earlier, and I asked her about the report and why she wanted to explore this area.
Two reasons. It was one, inspiration. I was checking out online who the Bank of Canada had shortlisted for to put on their note of women, and so Elizabeth McGill was one of those people featured, and I read through her bio and I thought she was a very interesting individual. The first electrical engineer in Canada back in the 1920s, went off to do her master's in the US to do aeronautical engineering, and then came back to Canada to actually work and develop on one of the most successful fighter planes in World War II. So it was just fascinating to have seen someone in the 1920s take that type of career stream. And then the intellectual curiosity kicked in as an economist, knowing that we're in a very digitized world and that this is an area that is very fast growing. I wanted to actually go out and measure how women have fared today relative to her pioneering efforts.
I think one of the more interesting things too, what you just said, is this incredible woman who I've never heard of until this actually came up, I think, which is part of the problem. So let's get into the problems right now. What is the problem you think you're addressing?
Well, you know, when you look at the STEM field, which is your science, technology, engineering, mathematics, that group of educational field, it is one of the areas that shows the fastest growth in employment. Post-recession, it was growing at a rate of 22%, so about 3 times what you were seeing in the rest of the economy. It's proliferating across industries. So it's not your big IT companies anymore. It's in financial industries. It's in manufacturing, utilities. So it's quite pervasive across the economy. And it naturally asks the question that women show a high propensity to get a bachelor's and master's degree in university. In fact, they make up 50% or more of graduates. Why is it that they're not in this particular area only at a ratio of 20 to 30% in STEM fields when it's one of the highest paying and fastest growing areas? And it became a concern because if you continue to see low representation of women in STEM fields, it could actually perpetuate the gender wage gap because the wage growth in that field is higher than what you see on average for the rest of the industries.
So the other thing I found interesting in this report is, again, women who are graduating not in the STEM field as compared to, again, the ratio of where they are in universities. Mm-hmm. The other thing I thought was interesting and a little upsetting was that when I read that even the women who are working in STEM fields aren't getting paid as much as men in the same fields.
Yeah, so there's an interesting phenomenon. This is something I learned just by peeling back the onion a little bit. So once women succeed in terms of attaining an educational vocation in STEM, going into the workplace, there's basically 2 avenues you could follow. You either go into a professional role, so a software engineer would be an example, or you could go into a technical role, so someone who tests the software as opposed to designs it. And the technical roles pay less than the professional. So professional out-earn by between 30 and almost 40% more than technical. And what we were finding is that women with bachelor's degrees in STEM were disproportionately getting put into technical roles. So they're choosing the higher paying field. You're still better off in a technical role from a pay perspective than on average other areas of employment. But it is the lower of the 2 areas. So it's perpetuating some of that gender wage gap that we're seeing by that occupational sorting that's happening in the workplace.
The one thing I thought was also interesting about this report is you delve a little bit into the prescriptive, which I think is a little not the typical thing that happens in a lot of economic research. What can be done? Because you also make the highlight that this is not an aptitude differential.
No,
this is not the case. So let's just put that away and stop talking about that. What can be done?
Yeah, so it was interesting because I was trying to find examples where when we looked at the ratio of women in engineering and computer science in particular, it's been quite stagnant. For about 10 years, you're not seeing that ratio improve very much. And in fact, in computer science, it's actually gotten a little worse because men are entering the field in such high numbers relative to women. So what we did is we said, what are some of the success stories of either countries or organizations that are able to move the dial in motivating more women to choose the field in education and then go into the workplace. And what we found is that there's a lot of initiatives happening at the university level, and we looked to the US market and found some really great examples. One school was Harvey Mudd, and another one is Stanford, everybody's familiar with. And these schools have put in place different, more targeted measures to maintain the interest of women in the field. So it's not for it's not for not preferring the field. It's not, what happens at the educational level is that women aren't seeing the career trajectory that's relevant to them. Mm-hmm. So, you know, if you think of computer science, most people think of gaming, but it's so much more than that. There's software being developed in the healthcare field, for example. And
it's pervasive in everything, like you said.
That's right. Yeah. And when they made that connection for women and showed the application from education into the workplace, they naturally were able to have more women choose that field and stick with it. So Harvey Mudd took their graduation rates up fourfold in the span of 4 years.
How does Canada compare to other countries in terms of just the spectrum, I guess, in terms of women in STEM?
It depends on the country. Like if you look at a country like Switzerland, for example, they have women participating in computer science and engineering about 10 percentage points higher than in Canada. So for example, engineering in Canada, about 20% of the work people graduating are women. And you go to Switzerland, you'll see those ratios rise by about 10% in the workplace. So there's higher representations happening there. Singapore is another example. China is another one. Korea. So it depends on the country. You will see some movement in the representation, and they take different tactics. So if you look at Singapore, they put a lot of focus on educational development of the teachers to help them make these connections into the workplace. And so they entitled them to over 100 hours of professional development. And one of the studies we looked at was a study by the Toronto District School Board that surveyed teachers who have a lot of interest in teaching this in the classroom, but don't feel they have the resources at hand. And in fact, 40% of those surveyed had trouble identifying jobs in the marketplace for students. So it's hard to teach a subject when you can't make that link, right?
Last question for you. What was the most, I guess, encouraging and maybe discouraging thing coming out of this report, or what surprised you?
I think most encouraging was that you are seeing very strong examples of universities who are having good success stories like those Harvey Mudds. And even a University of Toronto and Waterloo have recently seen their enrollments rate rise as well. Mm-hmm. So that was the encouraging news, that there is evidence that the dial is moving, and we should see evidence of that in the workplace 3 to 4 years from now when those people enter the workplace. Discouraging was the potential occupational sorting that's happening. What you don't want is a different standard for women entering the workplace than men. And so if women are being pushed into technical roles at a greater degree than professional, I think that's where the corporate challenge has to go out there to review their policies, their hiring practices, and even their mentorship programs that they're offering women. We want to make sure everybody's on an equal plane.
Great insight, Beata. Thanks very much.
My pleasure.
Beata Caranci, Chief Economist at TD Bank, joining us on the future of women in STEM.